Am I audible? Hello, hello. Am I audible? Okay, I think we need to start, right? Perfect, perfect. So, start. Okay. So, we're going to start with the first lecture of the series, that is basic mathematics, right? And we will try to finish this in, I hope, in 2 to 3 hours, from very basics to whatsoever it need to your examination, right? That is a NEET and JE. Okay, okay. So, one second. Oh, perfect. Hello, hello, Sunil. So let's start with the very first thing of this unit, that is trigonometry. And in trigonometry, we are going to discuss the first thing, and that is angle. What is basically an angle, right? So let us suppose we are having a line like this, okay, and let us rotate this line. We are dealing the 2D only. Let us rotate this line. So we are having two possibilities to rotate it. One, we can rotate this line in upwards like this. One downwards. One is downwards. Perfect. So let us suppose this is initial. This one is also initial, and after some time, this one becomes final point. Okay, this final. This becomes final. So whatsoever is the gap between these two lines, that is initial and final, this gap is known as angle. So this thing is known as angle. This one is known as angle, represented by theta. Okay, the notation of the angle is theta. Here also we are having theta. Perfect. If we rotate this line, after some time this line would be here, after some time it would be here, after some time it would be here, and after some time it will coincide with the initial point. Okay? That means if you can imagine, it is making basically a circle. It is basically making a circle. Perfect. So we can represent this line as a radius of the circle. Same is this case with this one. So we can represent this line as a radius of the circle. Okay, now this gap is known as arc length. This gap is known as arc length, denoted by letter S. Also, this side is known as arc length, denoted by letter S. Okay, now we are having a formula that relates this arc length, radius, and this angle, and that formula is angle is equals to arc by radius, or we can write that S is equals to r theta. S is equals to r theta, that is arc length is equals to radius into arc angle. Okay, this is the formula to measure the angle. Now, so we are having two possibilities, right? If you can look into the picture, we are having two possibilities. One, we can rotate the line in an anti-clockwise manner. Second, we can rotate this line in a clockwise manner. So if we are having two possibilities to rectify the issue, whether it is a clockwise or anti-clockwise, we are having some sort of sign conventions. We are having a sign conventions of it. So what are these sign conventions? So if you are rotating your line in an anti-clockwise manner, we are assuming the angle is to be positive. And if we rotate this angle in a clockwise direction, we assume it to be a negative. Okay, let us suppose we are having a line like this and we are rotating like this. So I think this is basically an anti-clockwise manner. So you can write theta will be a positive. In the same way, if we are having line this and we are rotating in a clockwise manner, this is clockwise manner, so we are representing it as a positive. Clear? Now look, if we are having a line like this and let us suppose the angle is given to be 30, so you will write it as a plus 30. In the same way, if the angle is given like this is 60, right? But the rotation is anti-clockwise, you can represent this as a minus 60. So here minus represented that you have rotated this line in an anti-clockwise, in a clockwise manner. Positive means anti-clockwise manner, right? Now we are having the units of the angle. We are having the units of the angle. Okay, so basically the units of angle is radian, and the symbol is RAD. It is basically a radian, right? And one radian, what is one radian? One radian is angle subtended by an arc at its center, which has length equal to radius. What is the meaning of sentence? We are having S is equals to r theta. If my arc length is 1 meter, my radius is 1 meter, there that means my theta would come 1, right? Clear? Okay, we can say it's 1 radius. Okay, one radian, RAD, 1 radian. Perfect. Now we have already studied in our lower classes that we are having a degree, minute, second. These are other units of angle also. Now we need to have the kind of knowledge by which we can manipulate the values. We can manipulate the equations between radian, between degree, between minute, between seconds. But for us, the most important is between radius, radian, and degree. Now we will try to figure out how to manipulate these things, right? Now look, if we are having a line like this and we rotate this line and we rotate this line, I think it is making a complete sort of circle, huh? So what would be the length of this dotted line? I think the length of this arc length, huh? This would be an arc length. I think the length of this arc length would be S, and that is 2 pi r. This one is 2 pi r. Clear? And what would be the angle at the center? It would be 360. Clear? It would be 360. Okay, so my S is nothing but it is 2 pi r. But what is arc length? It is r theta. So I can write as r theta. So r theta came out to be 2 pi r, which came out to be 360 degree. Okay. Or you can write it as a theta come out to be 2 pi radian. Theta is nothing but 2 pi radian, which will be equal to 360 degree. It would be 360 degree. Okay. So one complete revolution means 2 pi radian, and 2 pi radian means 360 degree. Now we are having 2 pi radian. 2 pi radian is equals to 360 degree. That means pi radian would be equals to how much? 180 degree. And what is 1 radian? 1 radian would be equals to 180 divided by pi, which is approximately 57.3 degree. Clear? Sure, definitely. You can share this link. Definitely, you can share this link. You can share this link. No issue. Okay. Now, so you can also write in this way, now. Just give me a second. I will just make it smaller. I will just make it smaller. 1 second. 1 second. You can write it as a theta would become 2 pi radian. That is 360 degree only. Okay. So if you want to convert, right? That means if you want to convert degree into radian, what you can do? So you have only that is theta, which is in degree, just multiply by pi by 180. You will get this function as a radian. If you want a radian to convert into degree, so you are having theta multiplied by 180 by pi. You will get this function as a degree. Clear? So we will do some numericals. Okay. We will do some numericals. Okay. Now, suppose we are having a question. I can write here. We are having a question 60 degree. You have to convert 60 degree into radian. How you can convert the 60 to radian? So if you are having degree convert to radian, you have to multiply it with by pi by 180. So it is 60 into pi divided by 180, right? 3. I think it would be pi by 3 radian. In this way, you can convert it. Okay. Now we are having some standard values that you must remember to get your answer in a very quick way. So we are having pi by 2. Pi by 2 is a 90 degree. We are having pi. Pi is 180 degree. We are having pi by 3. It is 60 degree. Pi by 6, 30 degree. And pi by 4, 45 degree. Okay. You can write a 2 pi by 3. It is 120 degree. And you are having 5 pi by 6. It is 150 degree. Or 3 pi by 4, it is 135 degree. Okay, if you can remember this formula, it will be better for you to just have your numerical done in a very quick way. Clear? Now we are having a relation between arc length and arc angle. So that is basically S is equals to R theta. Okay, S is equals to R theta, but here theta should be in radian only. In a radian only. Theta should be in radian only. Okay. Now we are having a numerical. Numerical is find length of arc of radius 4 meter. So we have to find the length of arc. That means we have to find our S. And the radius is given as 4 meter. So radius is 4 meter. Radius is 4 meter. Okay. And which makes angle 90 degree. Angle is given as theta is equal to 90 degree. So firstly we have to convert this 90 degree into radian. How can convert it? How can convert it? 90 degree into pi by 180. Okay, it will become pi by 2 radian. Now I think S equals to R theta and S is, we need to find out, right? R is 4 and it is pi by 2. It is 2 pi meter. Clear? Any confusion? Any confusion? I think we are observing some lag, right? We are observing some lag. Good morning, Arushi, good morning. Okay, let's move ahead. Now we are having some trigonometric ratios. What are these ratios? These ratios will help you to get the values of angle of sides if one side and one angle is given, right? How you can do it now? Let's suppose we are having, okay, just give me a second, 1 second. One second. Okay, now, so let us suppose we are having a right angular triangle. Okay, this is right angle triangle. And if this is an angle theta. So we know that this side is base and perpendicular and hypotenuse. So what is Pythagoras theorem? That is hypotenuse square equals to perpendicular square plus base square. Okay. Now we are having some trigonometric ratios. What are those ratios? Those are sine theta. Sine theta. P by H. Cos theta. B by H. Now we are having tan theta. P by B. We are having cosec theta. H by P. Sec theta. H by B. And cot theta. B by P. Also you can write sine theta by cos theta. It is tan theta. Okay, these are the trigonometric ratios that you will just apply in your upcoming numericals. Okay, look, now we are having some identities. You need to remember all of these, right? You need to remember all of these. Okay, so that when we start our upcoming chapters, you will find the application part of this basic maths, right? So if you remember in my previous classes that we are having interaction with you, so if if let us suppose we are having 100% to be done, okay, so only 30% is a physics concept. The rest all of these of things are the summation of basic math, summation of units and dimension, summation of vectors. So you need to have very good hand on these chapters. Now what identities we are having? First identity, that is sine square theta plus cos square theta is 1. 1 plus tan square theta sec square theta, then 1 plus cot square theta, it is cosec square theta. Okay, these are some identity that we need to remember. This is some sort of numerical given to us. For the triangle sine theta, there is theta. Sine theta is 3 by 5. Find all the trigonometric ratios. Okay, so for it we need a triangle. That's what is the triangle, and this sine theta is given, right? Sine theta is given as 3 by 5. It is p by 8. So perpendicular is 3, hypotenuse is 5. This is theta, right? What will be now base? We know that hypotenuse square equals to perpendicular square plus base square. So hypotenuse we are having 5 square. Perpendicular is 3 square plus base we don't know. So 25 9 b square, 16 b square. So you can write b came out to be 4. This is 4, right? Now what is all the trigonometric ratios? So we are having cos theta, tan theta. This base is 4 and hypotenuse is 5. It is 4 by 5. Tan theta is p. P is perpendicular by base is 4. So you can get the numericals done like this. Okay, very easy. It's very easy, huh? Okay, now we are having table for trigonometry. You need to remember this table. So we are having function is sine theta. We are having cos theta, tan theta. So it is 0 degree, 30 degree, 37, 45, 53, 60 and up to 90 only. So what is cos? Sine 0 is 0, sine 30 is 1 by 2, sine 37 is 3 by 5, sine 45 is 1 by root 2, sine 53 is 4 by 5, sine 60 is root 3 by 2, sine 90 is 1. Now we have to reverse this, right? So what is cos theta? Cos 0 is 1, cos 30 is root 3 by 2, cos 37 is 4 by 5, cos 45 is 1 by root 2, cos 53 is 3 by 5, cos 60 is 1 by 2 and cos 90 is 0. Sine by cos, so you will get 0. 1 by 2 divided by under root 3 by 2. I think it will become 1 by root 3. This will become 4 by 3. This one become 1. This one is 4 by 3. This is under root 3. This one is infinite, right? Or 1 by 0. This table you need to remember. You don't need to remember the values beyond 90. But why? Because we are having the rules by which we can break down the higher values. Okay, we know those tricks by which we can divide it. Okay, we can get these values. Now Let us suppose we are having values bigger than 90 degree. Then how we are supposed to deal with those problems? Now we are having ASTC rule or we are having four quadrant rule. That means, let us suppose we are having basically we are having a shape like this. Okay, it's a shape that we are having with us. We need to break down the shape into four quadrants. Okay, we will break down into four quadrants. That is four parts. Quadrant first, quadrant second, third quadrant, and fourth quadrant. Third quadrant and fourth quadrant. That we are having four quadrant, right? Okay, now this line gives you 0 degree or 360 degree. In a radian, this will give you a 0 radian or 2 pi radian. This line will give you 90 degree or pi by 2 or 450 like this. This line will represent 180 degree or pi or 540. This line will represent 270 or 3 pi by 2. Okay. Now, if your angle, whether these are sine, cos, tan, cosec, whatsoever angle you are having, whatsoever things you are having, right? So if your angles are lie between from 0 to this quadrant, that means in first quadrant. In first quadrant, all positive. In first quadrant, all positive. All these ratios will become positive. Okay, that is, let us suppose we are having a sine 45 positive, cos 45 positive, tan 45 positive, cosec 45 positive, right? Sec 45 positive, cot 45 positive. So whatsoever trigonometric ratios you are having, but between 0 to 90, all of these will become positive. Okay, now look, in the second quadrant we are having only sine and cosec positive. In third quadrant we are having tan and cot only positive. In fourth quadrant we are having cos and sec only positive. Clear? Suppose we are having angle like sine 225 degree. You need to give me the idea whether the angle will become positive or negative. Okay, so we are having sine 225. I think the angle 225, it is less than 270 and it is greater than 180, right? So the 225 will fall into third quadrant. Okay, so in third quadrant only tan or cot is positive, rest of all are negative. So I can write this thing is a negative. Clear? That's why we are having cos. So what is cos 225? Also negative. But what is tan 225? I think tan 225 is something that lies in the third quadrant. Also we are having tan, so it will become positive. So the ASTC rule works like this. Okay. Now we are having, just a second. Now, if my argument, that is mean if my theta is above 90 degree, then how we can deal with it? So here we are having, it is n pi, it is n pi, it is n pi plus minus theta. So first trigonometric reduction rule is, so trigonometric function of any angle n pi plus minus theta will remain same if n is integer and sign of trigonometric function will be same according to the value of that angle in quadrant. So what is the meaning of this sentence? You have to remember the angle should be acute. That means the angle should be less than 90 degree. Meaning like that, if we are having some angle, right? If we are having some angle, and this angle is bigger than 90 degree, and if we can break down the angle into this parameter 9 pi plus minus theta. So n is basically an integer, okay, a number, and theta is angle, but it should be acute, less than 90 degree. If we able to break down the angle into this uh, n pi plus minus theta, so what is the answer of my, what would be the answer of my numerical? Okay, how we can break down this thing now? We can do this by simple taking a simple numerical. So my question is, what is the value of sine 225? So is it possible we can break down this sine 225 into this parameter? Let's try. So I think 225, I can just break down this thing into 180 plus 45 degree. Okay, I think I can break down this thing into 180 plus 45. What is pi? Pi is 180. I think I can write this thing into sine 1 into pi plus 45 degree. Okay, so theta comes acute, that this is less than 90 degree. So n came out to be 1. So yes, we can break down this function sine 225 into sine n pi plus theta plus minus theta. Okay, now the function will remain same. The function will remain same. So you can write function is sine theta. It will remain same. It will remain same. So my answer will be sine theta only. Okay, it will become only sine theta, that is 45. But what will be the sine of it? So I think sine 180 plus 45 is third quadrant. In third quadrant, my sine is negative, so I had to put negative here. So my answer would be minus sine 45, and it is minus sine 45 is 1 by root 2. So my answer came out to be minus 1 by root 2. Clear? Okay. Clear, no? So if we can break down like this, so its function, if we are having something like that, if we are having function and n pi plus minus theta. So if we can break down like this, so your answer will become sine function theta, and this sine bit the before the function, it we can determine the sign whether it is positive or negative by ASTC rule. Clear? We are having second rule, the trigonometric function of any angle. If now this thing is common, that the angle should be less than 90 degree acute angle. Okay, if we are able to break down my function, that is how I am having a function sine theta. If we are able to break down this thing into function n pi by 2 plus minus theta, if we are able to break down the function like this, so function will change into co-function. It will change into co-function. Okay, and it is co-function theta, and before the positive or negative, we can determine it by using the which rule? ASTC rule. Okay, now what are these co-functions? For sine we are having co-function cos, for cos we are having sine, for tan we are having cot, for cot we are having tan, for sec we are having cosec, for cosec we are having sec. Function, co-function. Let's take one example to get it clear. Take one example. If same sine 225, I think I can do like this now. Sine 270 minus 45 degree also. Okay, so we can represent this into that. It is 270. Okay, so I think this is similar to this one now. Yes, so we have to change this now. Firstly, 270 minus 45 means the third quadrant. In third quadrant sign is negative, so put negative. Sign will change to cofunction, that is cos. It is cos minus cos 45. It is minus cos 45 1 by root 2. My answer came out to be same. Here my answer is same, minus 120 minus 1 by 2. Here I am having minus 1 by 2. Now we are having third rule of it. We are having third rule. Trigonometric function of any angle. If we are having any function with an angle theta, okay, and if we are able to break down this thing into n pi plus minus theta, n pi plus minus theta, then n is a whole number, then function will remain same. The function will remain same. We are not going to change function, it is co-function. Okay, that's why we are having sine to n pi plus theta, so we will get sine theta. If we are having cos to n pi plus theta, we will get cos theta. If we are having tan to n pi plus theta, we will get tan theta. Okay, rule number third. This one is not very useful. You can have the first two rules. This one is also important. We are having some negative arguments. This arguments means theta. So if we are having now negative arguments, let us suppose we are having sine is minus theta. So if we are having sine minus theta, so sine minus theta will become minus sine theta. If we are having cos minus theta, so this will become plus cos theta. If we are having tan minus theta, so it will become minus tan theta. Okay, I will take one example to get it clear. Let's suppose we are having a question, and the problem is like sine minus 120 degree. So my argument, that is theta, is in minus, so I can do like this, no? First step, take minus outside, it become minus sine 120 degree. Now I have 120 degree, I can break down it, right, according to my trigonometric reduction rules. So it is minus sine 120 would be sine 90 plus 30. Okay, it is 90 plus 30, that means it is n pi by 2 plus minus theta. So we have to change this function to co-function. So look, 90 plus theta is second quadrant. In second quadrant, sign is negative. Sorry, the sign is positive. I can write positive. Then we are having sine 90 plus theta, so sine get changed to co-function cos, and it will become theta. So plus minus is minus, so I can write minus. It is cos 30 degree minus. What is cos 30? Under root 3 by 2. This one is my answer of a numerical. Now we are having some identities, very, very important identities. So if we are having, give me a second. So let us suppose if we are having one minute. If we are having sum and differences formula. So what is sine A plus B? It is sine A cos B, and here we are having plus minus cos A sine B. That means if we are having the identity like this, no, sine A plus B, so you can write it in a manner sine A cos B plus cos A sine B. And if we are doing sine A minus B, so it will become sine A cos B minus cos A sine B. The same way, if we are having cos A plus B, so I can write cos A cos B. It's plus, this becomes negative, it is minus sine A sine B. Now if we are having here sine A minus B, so it will become cos A cos B plus sine A sine B. In the same way, if we are having tan, this tan A plus B, so this will become tan A plus tan B whole divided by 1 minus tan A tan B. And if we are having minus, so here we are having minus, here we are having plus. These are some identity that we are having with us. Okay. Shukriya sir. Okay. Now look, we will do a couple of numericals. No, we are not having numericals, right? We are having some different identities as well. Now we are having double angle and half angle. So let us suppose we are having double angle. What does this mean, right? So let us suppose we are having, at the place of A we are having A, at the place of B we are having B. That means the same angles. So I think it becomes sine A plus A, that is sine 2A. Here we are having, I can like this, no? Here I will just represent it. Okay. So we were having like this. Now I can write sine A plus A, it will become sine A cos A plus cos A sine A. I think this sine A cos A, I can write this in this way. The sine A cos A plus sine A cos A. So I can represent it as what? 2 times sine A cos A. So this is a double angle formula. This one is double angle formula. Okay. Now we are having cos 2. This one is important, no? This one is important. If we are having cos 2A, how we can manipulate with the cos 2A? So the cos 2A I can do here, no? How we can do cos 2A now? So cos 2A. So we are having cos A plus B. So I can write cos A plus B. B is also A. So it will become cos A cos B cos A minus sin A cos A. It is sin A, no? It will be sin A only. Sin A sin A. So this will become cos square A minus sin square A. One identity. Now we are having cos square A. I can represent cos square A by 1 minus sin square A and minus sin square A. I think this will become 1 minus 2 times sin square A. Second identity. So we can represent it this way, no? So I can represent also this is cos square A minus. So sin square A I can do it as a 1 minus cos square A. So this will become cos square A minus 1 plus cos square A. So I can represent this thing into 2 times cos square A minus 1. So we are having 3 identities of cos 2A. We are having how much? We are having 3 identities, right? These are very important. Okay. In 12th electrostatic, magnetism, or in kinematics, we are using these formulas. Okay. These are important. Only these 2 are very important. Now we are having half angles. Half angles means if my angle is A, now half means A by 2. Half means A by 2. Okay. Now if we are having sine A, it will become sine 2A by 2. That means here, if we are having 2, right, we can do here 2. Here 2 also. It means just half angle. There is sine A. It will become 2 sine A by 2 cos A by 2. It's not like that. These are not tough formulas. Now we are having a range. We are having a range of my formulas, right? We are having range. So for sine theta, no? So the range of sine theta is less than equals to 1 or greater than equals to minus 1. Okay. Now we are having cos theta. It is less than equals to 1, greater than equals to minus 1. The highest value of tan would be finite and the lowest would be minus finite. Infinite. Okay. Also, this one is not important. Okay. Now we are having small angle approximation. This one is somehow important for JEE aspirants also. This one. If we are having some angle, no? We are having some angle theta. And if angle is approximately less than 5 degree, you can take it off of 6 degree, right? 6 to 7 degree. If my angle is approximately less than 5 degree, then how we can manipulate with it? Okay, how we can manipulate with it? So if we are having sine theta, so sine theta will become only theta. Tan theta will become only theta. But cos theta will become only 1. But the theta should be in radian. Angle should be in radian. What is the meaning of it? So I will do one numerical so that you will get a very better understanding of it. Only on Sundays, no? Only on Sundays. Okay. Now, let's suppose we are having a numerical. What would be the value of sine 1 degree? Firstly, we have to convert the degree into radian. So I think I can write this sine 1 degree is nothing but 1 into pi by 180 radian. So now I can write this thing into sine pi by 180 radian. It is approximately pi by 180. Okay. Now also if I am having tan 1 degree, so I can write it as a tan 1 degree into pi by 180. It will become now radian. So I can write this thing into now tan pi by 180. Now I can write this thing into pi by 180. This one is the meaning of it. Now if I write cos 2 degree, value is straightly 1. Value is straightly 1. Okay. Now we have completed our trigonometry. We will do now coordinate geometry. We'll do now coordinate geometry. In coordinate geometry, we are having these terms. One is origin, axis, or the polar of it, that is axis. Okay. Origin means any fixed point. Any fixed point in space. If this is my space, so this is my origin. Okay. So what is axis? It is any fixed direction passing through origin. So let us suppose this one. This one is in a straight line and it is passing my origin. No, I will take it some. I will just mark it as the x. This one also. This one is y. This one also. Let us suppose this is z. So we are having 3 axes, right? So if we are dealing with the 3 axes, so we can call it as a 3D. If we are dealing with only 2 axes, that means maybe xy, yz, zx, we are dealing with that thing we are calling it as a 2D. Okay. Sometimes x we are saying this is abscissa and y is ordinate. You are not getting those things here. Those are very useless things, right? So origin and axis, right? I can do like this. So now we are having a distance formula. We are having a distance formula. So let us suppose we are dealing with 2D only. That's how we are dealing with 2D only. This is x-axis, this one is y-axis. This is my origin 0, 0. My particle initially was at this point and finally my particle is at this point. So initially my particle is at x1, y1 and finally, is this thing visible to you? Let me just clear. No, it's not visible. So I have to make this thing somewhere else. So look. If just one second. if we are having like this. Okay, this is x-axis, this one is y-axis. If my particle is at firstly at here, after some time my particle is at this point, right? So the coordinates would be x1 y1, then x2 y2. What is the distance traveled by particle in this particular path? x1 y1 x2 y2. So I think I can do like this, no? I can just make it like this. So this one is x1, this one is x2, this one is y1, this one is y2. And I think this gap represents x2 minus x1. This gap represents y2 minus y1. I think this becomes a right angle triangle, no? This becomes a right angle triangle. This is base, this is perpendicular, this one is hypotenuse. Now how to find the hypotenuse? We know it. So let's suppose this is D. So the hypotenuse is D. So I can write hypotenuse square D square would be equals to my perpendicular plus base square, or base plus perpendicular. My base is what? x2 minus x1 square plus perpendicular is y2 minus y1 square. So my distance between 2 points in a space or in a plane came out to be x2 minus x1. If I are dealing with two axes, y2 minus y1, like this. Okay, so in 2D my D formula came out to be under root of delta x square, delta x means x2 minus x1, plus delta y square means y2 minus y1. If we are dealing with 3D, so we have to introduce one more axis, that is x, delta x plus delta y plus delta z. Okay, now if we are having slope of a line joining 2 points, how to find the slope of a line joining 2 points? Okay, let us suppose we are having a system like this. Let us suppose this one is x and this one is y. This is 0 comma 0, and we are having 2 points here. Like this. Okay, my points here, first point is here, second point is here. This one is P, this one is Q, and this is x1 y1, this one is x2 y2. Clear? And the angle, let us suppose the angle is theta. So I can do like this. This one becomes delta x, this one becomes delta y. So if this is theta, this is also theta now. Okay, now what is my tan theta? P by B. What is my P? Delta y. What is my B? Delta x. Okay, so you can write also, this thing is also represented by m. So m is the slope of this line, tan theta is slope, delta y by delta x is slope. If you want to find a slope of a straight line, so the slope looks like a perpendicular by base, or delta y by delta x, or simply m, or simply m. Okay, okay, now we are having a general equation of a line. So this one is the general equation of this one, no? Y equals to mx plus c. This one is the general equation of a line, in which what is y? Y is basically a slope. And what is slope? Slope is a tan theta, that is m, which equals to delta y by delta x. Okay, x is coordinate. What is c? What is c? C is intercept on y-axis. It is intercept on y-axis. Okay, look, if we are having something like this, x-axis and this one is y-axis, and let us suppose this angle is theta. If here I can write, if my theta is less than 90 degree, that means if my angle is acute. If my angle is acute, so in this way my slope will become positive, because tan from 0 to 90 is a positive, and in second quadrant it is negative, in third it is positive, in fourth it is negative. So if my theta is greater than 90, that is obtuse, so my m is also a negative, and my theta is, if my theta is 90, that means right angle, so my slope came out to be infinite. If my theta is 0 degree, so my slope came out to be 0. Clear? Okay. Now look, acute means like this. This one will be acute. Theta is less than 90. Obtuse. Theta is greater than 90 degree. This one. Just 90. This one. On this line. Okay. Here. Theta is 0 degree. Now, if line passing through origin, if my line is passing through the origin, that means if my c equals to 0, we are not having any intercept now. We are now having any intercept now. That means it will looks like this now. Okay, c in this case c is 0. If we are writing, if we are making the things like this, so this thing is known as intercept c, and this is positive. If we are dealing like this, so this c here is negative. Okay, this is the meaning of the intercept on a y-axis. We are only interested in the y-axis. Now we are having intercept form of a straight line. That is, if we are having some straight line, but what its equation is in a intercept form, that means x2, x1, y1, y2, in this way. Firstly, this y equals to mx plus c, y equals to mx plus c, this is basically a straight line form, right? Now if we are having an intercept form, so let us suppose we are having the thing like this. This one is x, this one is y, and my line is like this. Okay, this is 0 comma 0, this one will become now a comma 0, this one is now 0 comma b. If this side is a, if this side is b, how my equation would look like now? So it will become x divided by, it will cut x at a plus y, y will cut at b equals to 1. This is my intercept form of a straight line. Clear? Clear? We will take up one numerical so that you can have a better understanding. Let us have a numerical like this. This one is x, this one is x dash, this one is y, and this one is y dash. So my pointers here are 0 comma 2, this point it has minus 0 comma 4. So I think I need to get an equation. I need to get an equation. How I can write it now? We know that my equation is nothing but x by a plus y by b equals to 1. So x, what is a, is minus 4 plus y. What is b? B is 2 and 1 is 1. So I think I can transform the equation to y equals to mx plus c form also. How? Look, now I can write in this way now. Y by 2 is equals to x by 4 plus 1 now. So I think y now becomes 2 times x by 4 plus 2. So I can write y came out to be 1 by 4 into 1 by 2. Sorry, it's 1 by 2. It would become now 1 by 2x plus 2. So here you can get all your values. My c intercept is 2, my slope m, it comes out to be 1 by 2. That is positive. That means my angle would be acute angle. Yeah. Also, you can have my angle is acute angle, and the intercept is a positive. Now my intercept is 2, right? The angle is how much? 1 by 2. Clear? Now we are having slope of a curve. Now we are having slope of a curve. Now let's suppose we are not having any straight line. We are not having any straight line. Okay. Now we are having some line which is having some sort of curve. How we can deal with this type of things? Okay. Let us suppose how we are having things like this. Okay. Now if my slope is like this, how I can deal with this slope? Okay, firstly, take more than 2 points. Let us suppose my 1 point is here, second point is here, third point is here. We are having 3 points, right? So make a tangent at these 3 points. First tangent theta 1, second tangent theta 2, third tangent theta 3. What you will observe here, theta 1 is less than theta 2 and is less than theta 3. So my theta is increasing at each and every point. My theta is increasing. Okay. Now you are having this sort of numerical in your NEET PYQs or also in your JEE PYQs. That tells me whether this curve is an increasing or a decreasing curve. Okay, whether the magnitude of this curve is increasing or decreasing. You will face this type of numericals in your examinations. So you can have one thing now. What? That theta 1 is less than theta 2 and theta 2 is less than theta 3. Okay, now first, and all of these, the theta 1, theta 2, theta 3, these are less than 90 degree. That means acute. If theta is acute, so my tan theta, if theta is less than 90, it is positive. If this is positive, so I can write my slope will be positive. Okay, and from 0 to 90 degree, my theta is increasing. My theta is increasing. If my theta is increasing, so I can write my tan theta is also increasing. My tan theta is also increasing, so you can write my tan theta 1 is less than my tan theta 2, which is less than my tan theta 3. So it is an increasing one. This one is an increasing one. Clear? This one is an increasing one. Perfect. Now we are having types of a slope. First one, we are having increasing function. Let us suppose we are having graph like this. Let us suppose x is y. If we are having like this, second x y, if we are having like this, third x y, if we are having straight line. We had to comment on this, right? Firstly, if we want to comment on this, we have to take 2 or 3 points. Let us take 2 points. Let us take 2 points. 1 point here, 1 point here, 1 point here, and 1 point here. Also, no, 1 point here and 1 point here. Now we have to make a tangent. We have to make a tangent. This is theta 1, this one is theta 2, this one is theta 1, this one is theta 2. Okay, now theta 1, theta 2. As you can see here, now the theta is increasing. So you can write that theta 1 is less than theta 2. Now my tan theta 1 is less than tan theta 2. So you can say my m1 slope first is less than slope 2. First case. And in second case also, firstly you have to remember my theta is less than 90 degree in this case. Also in this case my theta is less than 90 degree. Clear? Now look, I think my theta 1 is greater than theta 2. So I can write my tan theta 1 is greater than tan theta 2. So I can write my m1 is greater than m2. This one. So you can write my theta 1 is equal to theta 2. So this is basically tan theta 1 is equal to tan theta 2. Or you can write it is a straight line. Why? Because slope is constant. Slope is basically constant. Perfectly. In this case, slope is increasing. Slope is increasing, and in this case, slope is decreasing. Slope is decreasing. Whether the slope is increasing or decreasing, you can now get it by this point, right? You can now just manipulate these things by the given thing that I have shown to you, right? Now we are having decreasing functions. How we can manipulate with these things. So you can do one thing also, na? So you can do one thing also. My increasing function you can do is theta is less than 90 degree. Okay. And my decreasing you can just put it as a theta is greater than 90 degree. Now XY graph is like this. Secondly, if we are having like this, XY. Third, if we are having like this. Now look, take first point, second point, make a tangent. Theta 1, theta 2. First point, second point. Make a tangent. Theta 1, theta 2. Also here. Make a tangent. Theta 1, theta 2. Okay, here. We are having trick here. We are having trick. If my theta is greater than 90 and theta 1, let us suppose the theta 1 is smaller. Theta 2, let us suppose it is bigger, right? If we are having some angle smaller, no, so take it as a 120 degree. Bigger one 130 degree. And what is tan 120 degree? Tan 120 is minus 1.7. And what is tan 130 degree? It is not 130, 135. And what is 135? That is minus 1. Now look, here, what you can observe now, this is smaller one, this is bigger one. So smaller one, I can take it as 120. Bigger one, I can take it as a 130 degree. 135, okay. I'm obsessed with 130, right? 135. And this one is basically minus 1.7. This one is basically minus 1. So you can easily observe that the magnitude of this one. So you can write this, the magnitude of this one is greater than magnitude of this one. Okay. So you can write magnitude of slope decreasing. Magnitude of slope decreasing. But slope is increasing. Okay. Why? Because minus 1.7 is a lower one and minus 1 is a bigger one. Okay. That means slope is increasing, the magnitude of the slope is decreasing. Magnitude of the slope is decreasing, but slope is increasing. Now second point, this one. Here also, this one is bigger one now, so I can write it as a 135. This one is 120. So it is minus 1, this one is minus 1.7. So you can write the slope is decreasing but magnitude is increasing. Clear? So you can write slope m1 magnitude is less than m2. So you can write now magnitude of slope increasing but slope The slope is decreasing. This one, slope is constant. Slope is constant. Okay. Now, we are having third type, that is horizontal and vertical lines. That means it's very simple, no? X, Y. We are having a line, this is the horizontal line, so in which my slope will be 0. Secondly, X, Y. If we are having horizontal line here, so that means my theta would be 90. 90 means my slope would be infinite. So my value of m is infinite. Now we are having average slope of a curve between 2 points. Average slope. How to find our average slope? Average slope means if we are having a curve and we want to define slope between two major points. How? Let us take a slope. And now we are going to start the differentiation part. That's why here average came into play. So if we are having a slope like this, okay, take 2 points, 1 point here and 1 point here. Give me a second. My first point is here and second point is here. Okay. So let us suppose this one at x1, this one is x2, this one is at y1, at y2. We know that at each and every point we are having different slopes. We know that at each and every point we are having different slopes. But let us treat the curved line as a straight line. Then how we can get the slope of this slope? Okay, then how we will get the slope of the curved line? We will take the average of all these values. We will take average of all these values. Okay, now let us observe the line as a straight line like this. Now this side, we know that this side would be x2 minus x1, and this side would become y2 minus y1, and this angle is, let us suppose, theta. So we are having tan theta. It is m is equal to tan theta, and it will become y2 minus y1 divided by x2 minus x1. So it will become delta y by delta x. So delta y means the average value. Delta x is also average value. Now let us suppose we are not interested in taking a very huge sort of intervals. We are interested in a very small bit of intervals. If we want to take a, let us say, slope like this, and we want to measure the slope at this particular point, what you can do? You can zoom it now. It will look like this now. Take like this. Small angle theta. This side we are having dx, this side we are having dy. Now what is my m? M is tan theta. And what is tan theta? Tan theta will become dy by dx. Okay. So this is instantaneous value or instantaneous slope. I can write here. This one is instantaneous slope. Instantaneous slope means the slope at a smaller interval of time. Clear now? Now, oh, okay, I have defined this one now. It is m equals to tan theta, which is equals to dy by dx. Perfect. Now we will start the calculus part. Now we will start the calculus part. Perfect. We will start the calculus part. Very interesting one and very important also. Okay. Now, in calculus, we firstly will define some functions. What is basically a function? Then we will define the differentiation. So what is function? A quantity y is called a function of x if corresponding to any given value of x, there exists a single value of y. Means, if we are having something like y is equals to x square plus x plus y. If we are having some equation like this. Okay. Now, let us take a x equals to y. If my x is 1. Now, what my y will become now? It will become 1 square plus 1 plus 1. It will become 3. So, y become 3. So, at x 1, I get only one value of y, that is 3. That means at a given value of x, if there exists only a single value of y, That means you can just confirm that the y is a function of x. So from this example, you can easily confirm that y is the function of x. Why? Because at every value of x, there exists a single value of y only. Okay, so you can write here y is a function of x, and you can write in this way y equals to function of like this. Clear? Any doubts? Now we will start the differentiation. What is basically a differentiation? Okay, differentiation means differentiation means we know that if we are having some value of x, to each value of x there exists a single value of y. Okay, now if we vary the value of x, what will be the effect of that changing of x into y? This thing we can call it as a differentiation. So if we are having x and we are changing the x into dx, so my y, what will be effect on my y? Okay, if we change the value of x, what will be effect on y? This is basically differentiation. So we can represent the differentiation like this: f dash x equals to dy by dx. Okay, now so I can do one thing also. Now x delta x dx, very large value, something a large value, extremely small value. Okay, x is a very large value, delta x is somehow a value that is the large between a large and smaller value, but dx is a very smaller value, extremely smaller value. Now we are having some formulas to for the differentiation. Firstly, we are having different derivative of constant function. So look, if we change something, no, if we change something, so if we change something, so is it possible that we can change the constant also? No. Constant means it is something that is having a fixed value. So I can say that constant, we can change the constant now. We can change the constant, right? So it simply means if my y equals to fx and it is some constant c. So if we differentiate it, so it will become dy by dx, or you can write it as a f dash of x. So you can do dc by dx and you will get 0. Why? Because the differentiation constant is also 0. You can't differentiate it. Let's suppose we are having 2. So you can do d by dx of 2. You will get 0. If we are having d by dx of 1 by 2, you will get 0. If we do differentiation of e to the power 2, you will get 0. If we do differentiation of sine 30 degree, that is 1 by 2, you will get 0. So differentiation of any constant function is 0. Perfect. Now we are having second rule, differentiation of or derivative of algebraic functions. So let us suppose we are having something like that: y is equals to f dash of f of x and it is equals to x to power n. What would be the differentiation of it? It will be the dy by dx. It is nothing but f dash of x. It will become now nxn minus 1. Nxn minus 1. This is a formula that we have to follow if we are having something like x to power n. Let us suppose we are having a question that means So if we are having a function x cube, so let us suppose y equals to x cube. So we want to differentiate it. That how we can do it now? My dy by dx will become nx n minus 3. My here n is 3. So you can do nx n minus 3, that is 3x 3 minus 1. So it will become now 3x power 2. Second, if we are having y equals to 1 by x cube, I think I can just write it as x minus 3. Now my n here is minus 3. So I can do y equals to minus 3. See, there is a lag, right? See, there is a lag. Everything is great. Let's start. Look, if we are having, it will be minus 3x minus 3 minus 1. So it can become y equals to minus 3 x to minus 4. So now I can write it as a y equals to minus 3 divided by x to power 4. Okay. By this way we can do it. By this way we can do it now. One second. If we are having third type of thing, that is constant multiple rule. Constant multiple rule, if we are having some variable, which variable we are having some constant, we can take constant outside and we can do only differentiation of the variable portion. Let us suppose we are having y equals to x, f of x, and it equals to some constant c with some variable u. So how we can do it now? It will become dy by dx. It will become f dash of x. I can take c outside and differentiation of u with respect to x. U is a function of x also. Now we'll take some numericals. If my question y is equals to 4x4, so I can do dy by dx. I can 4 outside. I can do differentiation of x to power 4 only. So 4 is outside. The differentiation of x to power 4 will be 4x 4 minus 1 and x n minus 1. So it will become 4 for 16 x to power 3. Clear? 4. We are having addition and subtraction rules. So suppose we are having y and y is u plus minus v. Plus is addition, minus is subtraction. And u is also a function of y, v is also a function of y. How we can do it now? So dy by dx, take du by dx plus minus dv by dx. How to do it now? If we are having some numerical, if we are having some numerical, y is equal to x to power 3 minus x to power 2 plus 5x. How we can do it now? So I can do only one thing, dy by dx. It will become 3x square minus 2x plus 5. Okay. One more. If we are having y equals to x to power 2 minus 1 divided by under root of x plus 5x square. So I can do dy by dx. So x to power 2, that is x power n, that is nx n minus 1, nx n minus 1 minus 1 divided by under root of x. So it will become, no, I can firstly, I will simplify it. No? I will simplify it. So this will become now y is equals to x to power 2 minus 1 divided by x to power 1 by 2 plus 5x square. So my dy by dx came out to be 2x. It is minus. Okay, I have to simplify it one more time, right? So it would be y equals to x to power 2 minus x minus 1 by 2 plus 5x square. Now y will do now differentiation, dy by dx. This is 2x minus 1 by 2x minus 1 by 2 minus 1 plus 5x, that is 5 2x only. That is 2x plus 1 by 2x minus 3 by 2 plus 5 to the 10x. This one is my answer. Clear? Now we are having trigonometric functions. So if we are having y is equals to sine x, so what will be the differentiation of it? Dy by dx of sine x. So differentiation of sine x came out to be cos x. In the same way, differentiation of cos x is what? Minus sine x. And we are having now tan x. So differentiation of tan x came out to be sec square x. Okay. Differentiation of cot x come out to be minus cosec square x. Differentiation of cosec x came out to be minus cot x cosec x. So we are having sec x. So differentiation of sec of come out to be sec x tan x. Okay. Now let's do one numerical. Let's do one numerical. We are having a question that is y is equals to sine x plus cos x plus 2x cube plus x square plus 5. So what would be differentiation of it? Dy by dx. So sine x we are having cos x we are having sine x. It is 2, it will become 3x 3 minus 1 plus it is 2x 2 minus 1 plus 0. So this will become my cos x minus sine x plus 3 to the 6x square plus 2x only, right? This is the answer of my question. Now we are having logarithmic and exponential functions. How we can do it now? So if we are having exponential functions and if we are having log functions. So for log, if my y equals to log base e or x, or simply I can write it as a ln of x. So my differentiation of this thing into a, this is function, right? So I can write it as a 1 by function, 1 by x only. Clear? Now exponential. So exponential is e to power x. So I can do one thing now. I can write whole term, then differentiation of power. Whole term, if we are having ex, so I can write ex. D by dx, so power is x, so I can write ex into 1, that is ex. That's suppose I am having e to power 2x. How I can do it now? E to power 2x, differentiation of 2x. So it will become 2e2x. Clear? Same here. If we want to increase it now, it is differentiation of x. That's why we are having 1 by x into dx is 1. So I get 1 by x only. Now if we are having product rule, if we are having product rule, that means y is equals to uv. Y is uv. How we can do it now? It is dy by dx. It is, you will take outside differentiation of v with respect to dx plus v outside du by dx. It's a rule that we have to follow, right? Let's take one example to get it. If my question is like y equals to x square sine x, treat this as a u, this as a v. So how we can do it now? So let's take x square common, x to outside and differentiation of sine x, then plus sine x differentiation of x square. Now you can write it as this way: x square differentiation of sine x is cos x plus sine x differentiation of x square is 2x. Now my answer came out to be x square cos x plus 2x sine x. Okay, perfect. If we are having some quotient rule, that means if we are having some function u by v form, if my, so how we can do differentiation of it? Dy by dx. But remember, u and v both should be the function of x. So I can write it as a v square, v outside differentiation of u with respect to x minus u outside differentiation of v with respect to x. This is my standard form of it. That's how we are having y function, y equals to sine x by cos x. Okay, so how I can manipulate this now? So dy by dx would be equals to cos, so it will become cos square x. Then I have to take cos x outside, then differentiation of sine x only, then minus sine x differentiation of cos x only. So cos x, what is the differentiation of sine x? Also cos x minus sine x. Differentiation of cos x minus sine x, whole divided by cos square x. Now I can write here, right? Now it will become cos square x, it is plus sine square x divided by cos square x. So it will become 1 divided by cos square x. Okay, 1 divided by cos square x is sec square x. So my dy by dx came out to be sec square x. Okay. Okay, now so if we are having a chain rule, it is not something that is very tough to us. So what is chain rule basically? If let us suppose we are having y and y is a function of u. Y is a function of u, it is not a function of x. Then how we can do the differentiation of the function which is not the function of x? Okay, now dy by dx only. I can do differentiation of u with respect to x, or I can do differentiation of with respect to u only multiplied by du divided by dx. This is weird, no? I will look at some sort of examples and get it clear to you. So let's suppose my question is like if y equals to u square and u is not function of x. How we can do it now? So I can do dy by dx. It is 2u du by dx. Simple. One more. If my is equals to v square and I have to find out, no, it is not in your, let's suppose in your thing, right? I can take this one. We can do like this. Okay. Now we are having power chain rule. That means we are having something which is not a function of x. Also, we are having power on it. So let's suppose we are having y is the function, y is u and u is n, and u is not a function of x. How we can do it now? We have to nullify the power first. So I can do dy by dx. I can take power outside, that is nu n minus 1. Then I can take du by dx only. Let's suppose we are having numerical. If we are having y equals to sine u, not as sine x. Okay, how we can do it now? So I can take dy by dx. Sine u, we are having cos u, then du by dx. Okay. Any confusion? If we are having now application of derivatives, what is the application of derivatives? Okay. Look. So if my function is, we are having y and y is a function of x. If we want to differentiate it, so I can do dy by dx, and it will come out to be f dash of x. I can do a double differentiation of this also, right? So we can write d square u by dx square. It is equal to f double dash of x. This one will be double differentiation. This one is double differentiation. Okay. What we can do with this double differentiation? Let's take an example of it. Let us, so we are having the area, it is area, right? We are having a couple of mistakes in PPT. So the area of a circle is related to, it is, just give me a second. If we are having area A, the area of a circle is related to, is related by equation A equals to pi r square, is pi r square. Pi r square, how fast is the area changing with respect to the radius when the radius is 20 meters? Basically pure of differentiation question, right? We can do differentiation out here. Look, we have to find out how fast the area is changing with respect to the radius. That is, we have to find dA by dr. Okay, now I think area is given, area is pi r square. So differentiate dA by dr. So I can write just 2 pi r only. We got it. But we need to specifically at 20 meters. So what is r at 20 meters? So put this 2 into pi into 20. I think it will become 40 pi meters. This is the application of our differentiation. We have one more numerical. If side of a cube is changing by a rate of 5 meters per second, find a rate of change of its volume with respect to time when the side length is 4 meters. How we can do it now? Look, if side of a cube is changing to side, so let us suppose side of a cube is A. A is a side, so I can write dA by cube, na? Just T. that is 5 meters per second. Then find a rate of change of volume with respect to time. So I have to find out this dv by dt. How I can do it now? We don't know. So I will write volume. We don't know, na? So what is volume? I think volume side cube, that is a cube. So we want dv by dt. It is not function of a, or it is not function of t, na? So how I can do it now? So I will do one thing. It will become 3a square and dA of dt perfectly. 3. What is a? A is 4 meters. So I can write 4 square. A is 4 or something else? Yeah, it is like a 4 meter. Yeah, 4 square, right? What is dA by dt? It is 5. It is 3 into 4 for 16 into 5. Okay, this is my answer. 16 into 15. Okay, so this is my answer. Now we can do also one thing. Now we can do maximum or minimum of this thing also. Okay, one more application part of it, that is maximum and minima. I think I have written here, no? Okay, I will do a maximum minima. Okay, maximum minima. What is maximum minima? Let us suppose we are having a graph like this, xy, and we are having curve like this. So I think this is the highest point, so I can call it as a maxima at y, that is y max. This one is as a minimum point, so I can call it a y minima, y minimum. Okay, and x minima is at which point? X1, and minima is at which point? X2. So we have to find out whether the graph is a maxima or a minima, whether the equation is a maxima or a minima. We can do these things, right? So we have to follow some steps to get it. So let us suppose now we are having maxima, right? Let us suppose we are having a thing like this. Okay, so this, I think this one is a maximum point y max at x. If I just ask you what is the slope at this point, so you can take the tangent at here and you can write the slope at the highest point is 0. Why? Because thing is 0, right? Slope is 0, theta is 0. Now you have to follow certain points to get whether the maximum or minima. Place dy by dx at 0, do differentiation and just equate it to a 0. Secondly, find roots. You have to find roots of x. Thirdly, what you can do now? Do double differentiation. Do double differentiation. If you double differentiation, now if there is a chance you will get positive or you will get negative. If negative came out to be, you will say this is maxima. If positive, you will say this is minima. Clear? Now, is this one clear to you now? We will do some numericals and this thing will be very clear to you guys. One more thing, if we are having something like this point is a y minima at, let us suppose, at some x. So you have to take some steps, right? So y dy by dx, place it as 0. Second point, roots of x. Third point, double differentiation, d square y by dx square. If you got positive or negative, if you got negative, right, that is maxima. If you got negative, that is minima. That is minima. Now we have integration. Now I will take some examples to get it clear. Look now. Now we are having equation. The equation is like y is equal to x square minus 2x plus 5. We are having this equation. We have to find whether maxima or minima is present in here. So what we can do now? Take dy by dx. I think it will become 2x minus 2 only and place it equal to 0. So I think my 2x will become 2 and x will become 1 only. So this x is a critical point. This point is known as the critical point. Now we need to check whether at this particular x, whether the curve is at maxima or minima. Okay, we have to find it out. Now look, what you can do now, we will do double differentiation, d square y by dx square. I think my value come out to be 2x minus 2. My value outcome out to be what? Only plus 2. So that means at this particular point, the graph is at minima. But what is the minimum value? What is my minimum value? So you can write y minima or minimum value. So this is my value, x square minus 2x. So I can write 1 square minus 2 into 1 plus 5. So I can write 1 minus 2 plus 5. I can write minus 1 plus 5. I can write 4. So this point is a 4. Okay, I got this point. So you have to manipulate your equation like this. Very easy, very easy. Clear? So it's very easy. Perfect. Okay. Okay, we will do one more now to get this one done. If we are having y equals to minus x square plus 4x, so my dy by dx would be equals to minus 2x plus 4. Take it as 0. So my 2x is become 4. My x came out to be how much? 2 only, no? My x came out to be 2 only. Now look, add this 2 maybe we are at maximum. We need to find it out. So this point is a critical point. This point is a critical point. How we can find it now? Third step, to double differentiation. Now of this thing, I think we are getting only minus 2, and minus 2 is less than 0. That means we are having a maximum thing. So at 2 we are having maximum thing. And what is the maximum value? So y maxima. So I can write what? How to find a maximum now? It's minus x square, no? What is x? X is 2. So I can write 2 square plus 4 into 2. So it is 4, 8. Minus 4 plus 8, my answer is 4. So my answer is 4. If my graph is like this, so we are having at x2, graph is like this, so it is 4. Okay, now we will start now integration. What is basically integration? No? If you are having some bigger quantity and you want to go to the lower one, so you have to differentiate it. Now if you are having many lower quantities and if you want to go from lower to bigger, what you can do now? You can do the integration of it. Okay, for differentiation means you have to go from higher to lower. Integration means you want to go from lower to higher. You want to go to lower to higher. Differentiation means from higher to lower. Clear? Now look, also this integration is also known as the antiderivatives or the reverse process of differentiation. I can write here now. It is also a reverse process of differentiation. Integration means if you want to, integration is also summation part. That is summation. If you want to go from small to big or small to large portion, you have to do the integrations. You have to do then integration. Now what is the general formula for integration? If you are having fx function of dx, right? So I can write is the integration of dx. Now we are having two types of integrations. Firstly, we will do the indefinite. Indefinite means in which the limits are not given. So I can do f of it is equals to, this one is equals to f of x plus c. Now what is the c? C is known as arbitrary constant, also known as integration constant, also known as integration constant. So firstly we are having integration. Integration we are having two parts, definite and indefinite. Indefinite means in which the limits are not given. If limits are not given, so there is a chance of the error. To get the error rectified, so we have to place the constant c, and that constant c is known as arbitrary constant or the integration constant. Now we are having rules for integration also. We are having rules for integration also. What are these rules? So we are having first rule, that is the algebraic function. If we are having something in a algebraic functions, how we can do it now? Firstly, if we are having y equals to x to power n, we have to integrate it. How we can do it now? How we can do it now? Okay. So I will do the integration of this function. So I can do integration of x to power n with respect to dx. So it will become x. Whatsoever power is there, I have to put plus 1 and divide the same thing, right? The n plus 1 and plus c, arbitrary constant. This is valid. Exception is n should not be equals to minus 1. This thing is valid, but n should not be equals to minus 1. One more thing. If we are having 1 equals to 1 by x, how we can do it now? How we can do it now? So you can do it like x to minus 1, but here we are having minus 1, so this rule is not applicable. So we can do one thing, right? So if we are having function like this, so we have to apply the log. So I can do the integration of 1 by x to with respect to dx. It is nothing but ln of x plus c. Okay. If we are having y equals to ex, the differentiation of ex is ex, and the different integration of ex is ex only. So the integration of ex with respect to dx is only ex plus c. Okay. And the integration of constant k, if we are having some constant k, so integration of constant k with respect to dx would be equals to kx plus c. You have to remember all these rules. Now, secondly, we are having trigonometric functions. So if we are having sine x, so what will be the integration of sine x with respect to dx? It is integration will be minus cos x plus c. If we are having cos x, what will be the different integration of cos x with respect to dx? It will be sine x plus c. Okay, only these two are important for your syllabus. Now, if we are having rule number third, what is rule number third? No, rule number third, I can just apply here, right? If we are having third type, one second. If we are having something like this, if we are having u plus minus v dx, so take apart, right? Take separately u and v. So I can do integration of u with respect to dx plus minus integration of v with respect to dx. Fourth one, if we are having something constant fx dx, take a constant outside and do the integration of the function that we are having. Okay, let's take some numericals to get it clear. Look now, if we are having integration of x to power 5 with respect to dx, so it is the formula of x to power n, and n is not equal to minus 1, so I can write it as a x 5 plus 1 divided by 5 plus 1 plus c. So this will become x to power 6 by 6 plus c. One more, if we are having integration 1 divided by under root of x with respect to dx, so I can change this thing into x to power minus 1 by 2 dx. So n is minus 1 by 2, it is not minus 1, so I can use the x to power n plus 1 divided by n plus 1 plus c. So how I can do it now? So it is x minus 1 plus 2 plus 1 divided by minus 1 by 2 plus 1 plus c. So I can get it as a half plus 1, so it is x 1 by 2 divided by 1 by 2 plus c, right? So I can guess, I think his answer is under root of 2x plus c. Clear? One more, if we are having x square plus x plus 1, integration of this function, so x square will become x cube by 3, x will become x square by 2, 1 become x. Clear? Now we are having linear substitution in integration, very important. That means, firstly, if we are having function y equals to ax plus b power n, how we can do it now? So I had to do the integration of ax plus b power to n with respect to dx. Okay, so it is answer will be equals to ax plus b power n plus 1 divided by n plus 1, 1 divided by differentiation of ax plus b plus c. So I think my answer will become ax plus b power n plus 1 whole divided by the differentiation of ax will be only a, the differentiation of b is 0. So I can write it as a n plus 1 plus c. Very important for your syllabus. Okay. Also, second, if we are having y equals to 1 divided by, I think I can fit it here, right? Now, if we are having 1 divided by ax plus b, right? So you can write it as ax plus b power minus 1. If we are having minus 1, so we can do the previous one things, right? So what we can do now, if we have minus 1, we have to apply the log part. We have to apply the log. So I hope I can do it like log, now that is log of ln of ax plus b, and different 1 by differentiation of ax plus b, that is only what, a plus c. Third, if we have an exponential, if y equals to exponential ax plus b, so we have to do the integration of ax plus b power, the power is given na, dx. So it is integration would be equals to same ax plus b divided by the differentiation of ax plus b, that is a only plus c. Now we are having trigonometric functions. If my y is given as sine ax plus b, how I can do it now? Do the integration of with respect to dx. I think integration would be sine ax plus b, that is minus cos ax plus b divided by the differentiation of ax plus b, that is only a plus c. If we are having y is equals to integration of cos ax plus b with respect to dx, I think cos ax plus b, it is integration is how much? Sine ax plus b divided by the differentiation of ax plus b, that is only a plus c. We'll do some numericals also, right? Give me 1 second. Let's suppose we are having a numerical. That numerical is integration of cos 3x plus 4 with respect to dx. I think cos, that means this one, now we have to follow it. So it is value will be sine 3x plus 4 divided by 3 plus c. Okay. If we are having one more question, that is, it is integration of 1 divided by 4t minus 1 with respect to dt. So I think I can write ln of 4t minus 1 divided by 4 plus c. Okay. And one of my favorite numericals that we are having, that means integration of x to power e plus e to the power x plus e to the power e with respect to dx. This, how we can do it now? Look, x to power e, that means it is a purely case of what? Algebraic function. So I can write x to power e plus 1 divided by e plus 1. It is ex, so same ex exponential, it is e to power e, that means constant, 2.7, 2.7, it's constant. So I can write it as a e to power e plus multiplied by x plus c. Now we are having some important integration part, right? Very important in our 12th, or in this thing is important in 12th only. Okay, if we are having something like this, y is equals to integration of cos square x dx. I will show you only one. You have to do the second one by yourself, right? This one is first one, and second one will be like y equals to integration of sine square x dx. How we can do it now? So we can proceed the direct now. We cannot proceed here direct. Then how we can proceed now here? Okay, look, what is cos square x? What is cos square x? I think we are having an identity like this. Double angle formula, cos 2x and cos 2x becomes 2 times cos square x minus 1. We know it now. And now I think what is 2 cos square x? It becomes cos 2x minus 1. What is now cos square x? Cos square become cos 2x divided by 2 minus 1 by 2. So this thing we have to put na cos square x. So I can do one thing now. In the place of cos square x, I have to write cos 2x divided by 2 minus 1 by 2 integration of this part by dx. So it is u minus v. So I can split it out in the integration part of integration of 2x by 2 with respect to dx minus integration of 1 by 2 with respect to dx. So I can take 2 outside, it is constant now. What is the integration of sine 2x? Cos 2x. Okay, it would be sine 2x divided by 2 minus, what is the integration of minus 1 by 2? It is minus 1 by 2, right? Look, sine 2x, sine 2x. It's plus, right? It is plus here. Yes, it's plus. So it will become 1 by 2 into x only, plus c. So my answer is sine 2x divided by 4 plus 1 by 2x plus c. This is my answer. Second one. For this, right? Is your homework, you can do it. Same, you have to proceed now. Why? So formula you can use here now. One more formula that we are having, that is cos 2x is equals to 1 minus 2 sine square x. By using this formula, you can get it. Okay. Just give me a couple of minutes. We are going to finish the chapter, right? Just give me a couple of minutes only. Couple of minutes. Okay. Couple of minutes only. You need to give me only a couple of minutes and we will finish out. Okay. Look now, we are having different integration. Different integration means in which limits are given. Limit is given. Okay, if limit is given, so c won't be there. The arbitrary constant or the integration constant won't be there. So how we can proceed in this way, right? Let's suppose we have to integrate the function dy and limits are given as y1 and y2. How we can do it now? So this is basically a formula that is given to us. You don't need to remember this. Okay, this is something that I need to show you, right? You don't need to remember this. It is f of x ba. This is a formula that you need to understand or don't need to understand and don't remember it. Okay, I will show you how you can proceed in numericals. Also, this one is also important. This one is also important. Okay, so we will understand the whole setup, whole different integration by taking a simple example. Look now, if we are having x square, we need to differentiate x square with respect to dx, and the limits are given as 1, 2. Okay, no issue. So what is the integration of x2? I think it is integration is x to power 3 now. I can write x to power 2 plus 1 divided by 2 plus 1. Take a bracket and 2 I can write upside, 1 I can write downside. So I think I can write it as x to power 3 by 3. Upwards I am having 2, lower 1. So I can take constant, that is I can take outside, right? So I can take 1 by 3 outside. Internally I am having x to power 3 at this to 1. So where you are having x, put the 2. For it, you have to put upper value minus lower or upper limit minus lower limit. How you can proceed the 1 by 2, 2 power 3 minus 1 power 3. So you can do one thing, 1 by 3, 2 2s are 4, 4 2s are 8. You are having 8 minus 1. So that means 7. Answer is 7 by 3. Like this you have to proceed. Easy now? Easy? Okay now. So now we are having application part of it, right? We are having application part of it. We are having application part of integration, right? So within 15 minutes we will wrap it up. So we are having area. So yeah, area under curve. If you have to find out the area under curve, so you can use the integration. If you have to find average value over an interval, you have to use the integration part. Look, if we are having curve like this, if we are having curve like this, right? So curve that is given to us. Okay, if we have to find out this is x and this one is y. So let us find out the area under this curve. This is a very, this curve is having, this is not a straight curve, right? The curve is not a, this line is not a straight line, it's a curved line. So I can take a very small element. Take a very small element. I will take a very small element, and this portion we are having y. This, the width of this portion is dx. So I can, if I take it outside, no, so I can write it in this way. So it is dx. This one is y. So what will be this value? What would be this area of this one? No, I think it is area. It is a rectangle. It is area would be length into breadth. So I can write it as a y dx. Okay, it is value will be y dx. So if I take one more here, if I take one more here, it is area would be also, let's suppose y1 dx. If I take one more here, right, its value will also be also y dx. Clear? We have to sum all of these, so we have to integrate it. So the area under the curve will become integration y dx. Simple? Simple, huh? It's very simple, right? If this portion is a and this portion is b, take limit is ba from upper limit b to a. Take it. Also, we can take average value over an interval. Okay, I will make this thing understand to you. Okay, now I will take some numericals so that you can have a very clear view on integration. Okay, now let us find. We are having 4x with dx. Part is 2, 4. How we can proceed in this way? We are having 4x. I can take 4 common. Integration of x will be only x square by 2. Upper limit is 4, lower is 2. I can take 2 outside, is constant. It will become 4 by 2. Internally we are having x to power 2, 4, 2. 2 on the 2 to the 4. I am having 2. So in the case we are having 4 square minus 2 square. It is 2. 16 minus 4. Okay, it is 2. 12. 24. My value came out to be 24. Okay, one more. We'll do one more. We will do one more. We will do look now. If we are having integration of cos 2x dx from 0 to pi, okay, that means what is the integration of cos 2x? Sir, the integration of cos 2x will be sin 2x divided by 2. Upper limit is pi, lower limit is 0. I can take 1 by 2 outside is constant, so I can take sin 2x. Upper limit is pi, lower is 0. So I can take 1 by 2 upper limit sin 2. At the place of x I have to put pi minus lower limit sin 2 into 0, that is 0. It is 1 by 2 sin 2 pi, sin 3 is 60, it is 0, minus sin 0 is 0. So my answer came out to be 0. Okay, now we are having average value of function. We have to find out the average value of function. How we can do it now? Suppose we are having a function. So we are having a function. Y is equals to f to power x. Sorry, y equals to function of x. And what would be the average value of this function from x1 to x2? How we can do it now? Look. So the average value of this function would be equals to f of x dx x1 x2 whole divided by dx from x1 to x2. And this thing is very important. Why? Because in the kinematics you are having this one, EMI, AC you are having these things, right? In current you are having this one. To find the average value, V average integration x1 x2 Vx divided by or dt with function of dt also you can get it. Okay, in kinematics here we are having average value of function as a f of x dx from x1 to x2 divided by integration of dx from x1 to x2. Let's take one numerical to get a better understanding of this application part. Look now, if we are having a question like y is equals to x square and limits are given as -2, -1, 2, we have to find the average value of y. So what will be the average value of y? I think it is -1 to integration x square with respect to dx divided by from -1 to 2 dx. I think my integration of x square will be x 3 by 2, upper limit is 2, lower limit is 1, whole divided by integration of dx will be only x. Upper limit is 2, lower is -1. It is -1, no, -1. So I can take 1 by 3 outside. So it will become x to power 3, limit is 2, lower is -1, whole divided by x to -1. Clear? I think it is 1 by 3. I can write 2 power 3 minus 1 power 3, right? Whole divided by 2 minus -1. It is -1, right? So my answer is 1 by 3, 2 to 4 to the 8, 8 minus 1. It is minus minus plus plus 1. So we are having 2 minus minus plus is 1, 3. So 3 and 3. We are having 3 and 3 is 9, 9 by 9. So we are having 9 by 9, which came out to be 1. Which came out to be 1. So we have to find out the numericals like this, right? Now we are having quadratic equations. Firstly, we are having parabola. So quadratic equation is ax square plus bx plus c. If we are having something like this, so we can call it as a quadratic equations. Highest power 2 we are having. Okay. Now parabola, that means the graph of the quadratic equation is parabolic graph. So if we are having only y equals to ax square present, if only we are having like this, so this one is x, so my graph will look like this. It will touch it, right? It will touch it. You will get confused now. I have to make it like this. Graph will look like this parabola. If we are having y equals to minus ax square, my graph will look like this now. xy. If my equation is y equals to ax square plus c, some intercept is there, right? So we are having c here. If we are having x equals to ay square, now we are having x, so my graph will be on the x side only. If we are having x equals to minus ay square, my graph will looks like this now. If we are having y equals to ax square plus bx, you have to remember these graphs. So it will look like this now. Two roots, right? There are two roots. That's why it cuts at two different points. If you can get it like this, right? These are graphs. Now we are having quadratic equations. So we know that the quadratic equation is basically y is equals to ax square plus bx plus c. How we can get the roots out of it? Okay, that means x1 and x2. So basically my x1 or x2 are the roots or solution of it, and its value is minus b plus minus under root of b square minus 4ac divided by 2a. Clear? And we know that what? We know one thing, right? We know one thing, that is sum of roots or product of roots. This thing is known as what? D. Discriminant. Clear? Now look, if we are having x1 one root and we want to multiply it with x2, we can call it as a product of roots, and my product of root is basically c by a. And if I want to add these roots x1 plus x2, it came out to be minus b by a. And if my b square minus 4ac, if it is greater than or equal to 0, I can say roots are here, real roots. If my b square minus 4ac is less than 0, I can say my roots are imaginary. My roots are imaginary roots. You need to remember these things, right? Now I will take one numerical to get these things clear. One minute, 1 minute. This is x1 into x2. Look now, if I am having a question like this, x square minus 5x plus 6 equals to 0, and we have to find out the roots of it. How we can do it now? First one, I think x1 would be equals to minus b plus under root of b square minus 4ac divided by 2a. So minus b is minus 5 plus minus, but it's only plus na. It is only plus here, right? Under root of minus 5 square minus 4 into 1 into 6 whole divided by 2 into 1. So it is 5. It is 5 plus 5 is 25. 24 divided by 2. So I think my answer came out to be 5 plus 1 by 2. It is 5 plus 1 by 2. I think it is 6 by 2, which came out to be 3. What about the x2? x2 came out to be minus b under minus b square minus 4ac divided by 2a. So I can write it as a minus 5 minus under root of 25 minus 24 divided by 2. So it is also plus 5 minus 1 by 2. It is, I think, 4 by 2, which is come out to be 2. So we are having two roots, 3 and 2. Both are real roots. Both are real roots. Now we are having ellipse. So ellipse means if we are having something like this. So if we are having something like this, okay, look. So this one would be a major axis, this one is a minor axis, x, y. Let's suppose this would be a semi-major axis denoted by A, this one is semi-major axis denoted by B. Okay, so the thing is a major axis, this one is semi-major axis, this one is minor axis, this one is semi-minor axis. And it is important in your gravitation chapter. Okay, it is general formula is x square by a square plus y square by b square equals to 1. This is a general formula of ellipse. Okay, we don't need to get into it. Now let's take one numerical to get it, right? One numerical. Okay, it is very easy, no? Don't get it. If we are having circle, okay, so this one is the origin of our coordinate system, this one is the circle, a center of my circle, and its coordinates are a or b given. This is radius, right? This one is x, this one is y, and my equation of the circle is x minus a square plus y minus b square equals to r square. R the radius of circle. R the radius of circle. If center of circle coincide with the origin, what will happen then? A comma b both will, because both will become 0 then, right? So I can write only x square plus y square equals to r square. Perfectly. Let's suppose my question is like this. You will get an easy question from it, right? If my question is x square plus y square equals 30 square, 36. So what would be my r? Simple. It is x square plus y square equals to 6 square. So my R came out to be 6. Okay, now if we are having graphs, a sinusoidal graphs, if we are having sinusoidal graphs, that means if we are having, so the sinusoidal graph will look like this. It is graph will looks like this. Okay, this is add zeros, add, if my, let's suppose add x is 0, so add 0 and we can get sine 0, sine 0 is 0, I can sine 0. This one is at 90, at 90 we are having plus 1, this one is 180, 270, at 270 we are having minus 1. So the graph it looks like this. Now if we are having a cosine graph, so it starts from 90, right? So at x 0 we are having plus 1, at 90 we are having 0, at 180 we are having also 0, no, at minus 1, at 180 we are having minus 1, and at 270 we are having also 0. We are having, no, before binomial, before this thing, we are having some graphs, we are having graphs known as, one second, look now. If we are having, let's say my xy is constant, so you can say my y is inversely proportional to x. If you are having this formula, so you can say my graph is rectangular parabola, rectangular hyperbola, rectangular hyperbola. So my graphs will look like this now. Okay, my graph will look like this now. Let's say my y is inversely proportional to 1 by x to power 2, and my y is equals to 1 by x to power 3. Okay, and y equals to 1 by power x to power 1 by 2. So how you can represent the graphs here? Look, if we are having x, so y equals to x, so I can write this is y proportional to 1 by x. If you are having more power, so there will be a more slope. So this one would be y proportional to 1 by x square, this one would be y proportional to 1 by x to power 3, and this one would be y proportional to 1 by x to power 1 by 2. The graphs will look like this now. Okay, so we are having binomial theorem. What is binomial theorem? Binomial theorem you can use to get the square. If we are having some power 3, power 4, power 5, if you are having something like that, you will get your answer by using the binomial theorem. How you can do it now? So binomial theorem you are having like this. If we are having 1 by x to power n, by using binomial theorem I can expand it. So I can write 1 plus nx plus n minus 1 x square divided by 2 factorial plus n minus 1 n minus 2 x cube divided by 3 factorial and so on. Okay, and let's suppose the x is less than 1. If my x is very much smaller quantity, then means x square would be lesser than it and x cube will be lesser than it. So I can do one thing, I can take an approximation out of it. So I can write 1 plus x to power n, and it is approximately equals to 1 plus nx only. Clear? 1 plus nx only. If we are having 1 plus x to power minus n, I can write it as a 1 minus nx. If we are having 1 minus x to power plus n, I can write it as a 1 minus nx only. If we are having 1 minus x minus n, I can write it as a 1 plus nx only. You have to remember these formulas, right? You have to remember these formulas. Now we are having a numerical like this. 1 plus x square. How we can do it? It is not like it, no? No, it is numerical is wrong. It's not like it. So it is 1 to power, it is 1 power x to power n. It is like that. So you will get a 1 plus nx. Let's take a numerical to get clear. If we are having 1.001 power 10. How will we get the answer out of it? We can do one thing. Now we can use the binomial theorem. But for binomial theorem, I have to break it out 1 plus x, and x should be very less than that of 1. So I can do one thing now. I can write it as a 1 plus 0.001 power 110. I can do with this thing. I can all do this thing now. So it is 1 plus x to power n. So it is answer is 1 plus nx. So 1 is 1. What is n? N is 10. And what is x is 0.001. So I think it is 1 plus 101 cancel out. It is 0.1 now. 0.01, right? And my answer is 1.01 answer. It's my answer. You can get your question like this. Now we are having logarithmic relations. We are having logarithmic relations. If we are having log ex, okay, so you can write it here. Log ex equals to ln of x. And log ex, if my log ex is t, so I think you can get it, my x equals to e to the power t. Okay, if we are having log m into n, how you can do it now? It is log m plus log n. If you are having log m minus n, so you are having log m minus log n. If we are having log base e and m, so I can change it to 2.303 by multiply it. I can change it to base 10. If we are having log m power n, so I can take n outside. I can take log m only. Clear? You have to remember these values. And what is log 2? The value of log 2 is 0.301. What is log 3? Log 3 is 0.471 or 17. What is log 5? Log 5 is 0.699. Approximately you can take 0.7. And what is E? E is basically 2.71. One more thing. What is ln of 2? Ln of 2 is 0.693. Ln of 3 is 1.09. Ln of 5 is 1.6. 1 by E is 0.37. This table you have to remember, right? What is arithmetic progression? If you are having a formula like this, a comma a plus d comma a plus 2d and so on up to a plus n minus 1 to d. If you're having this term, right? This one is the nth term, the last one. And d is a common difference. A is first term, d is a common difference. A is first term, A is first term, D is common difference. D is common difference. How we can do it now? So you can do sum of first n terms. Sum of first n terms, that is S, and it come out to be n by 2, 2a n minus 1 into d. We can do also one thing now. It is n by 2 first plus nth term. One more formula, right? That's how we are having a numerical. So we are having a AP series, that is 2, 5, 8 and so on. We need to sum up the first 10 terms. And what is the 10th term? We have to find these two things. Okay. So firstly, what is A? A is 2. What is the common difference? What is different? That is successive terms different. That is 5 minus 2. It comes out to be 3. Now what is nth? It is A by 2. That is n by, no, but what are the difference? N by 2, no? N is 10. So I can write it's 10 by 2. And it is 2 times A. 2 into A is 2. Plus n minus 1. That is 10 minus 1 into common difference D. That is 3. So it will become 5, 4, 27. So I think it is 31 into 5. I think 155. So sum of first n terms is 155. Now if we want to find out 10th term, I think my one more formula is Sn equals to n minus 2 first term plus nth term. What is n? Sn, it is 155. N is 10 by 2. First term is how much? 2 plus nth term. So I think it is 155 into 2 divided by 10 minus 2 equals to nth term, right? So you will get 155 into 2 minus 20 divided by 10 into nth. So it is I think you will get 29 also. Value is 29. Value is 29. Okay. Now we are having last thing, second last thing, that is GP, geometric progression. If you having something like this, na, AR, AR2, like this up to AR n minus 1, AR n minus 1. A is first term, A is first term, and R is the common ratio. Common ratio, how we can do it now? So firstly, sum of n terms, that is Sn, it came out to be A 1 minus R to power n divided by 1 minus R. If we are having infinite GP, okay, so if we are having infinite GP, then what is the formula of Sn? It is only A divided by 1 minus R, because n tends to infinite. R times infinite, we can omit it, right? It is A divided by 1 minus R. Clear? We will do one numerical. Okay, we will do one numerical. Okay, let us suppose we are having a numerical, we are having problem 1 plus 1 by 2 plus 1 by 4 and 1 by 8 plus up to so on up to infinite. So we are having infinite GP series. What is A? A is nothing but 1. What is R common ratio? It is 1 by 2 divided by 1. It is 1 by 2 only. Okay. Now what is Sn? I think it is only A divided by 1 minus R, because it is infinite terms. So I think we are getting 1 divided by 1 minus 1 by 2. It is 1 divided by 1 by 2. It is 2 only. Okay. Anything that you want to ask me? Right? I think in 2 hours, right? Anything that you want to ask me? Anything? Okay, if not, then I will do one thing, no? So we can do one thing. We have completed our portion. Okay, so we have completed. So we have completed, right? Okay, now if you have any sort of suggestion or anything like that for me, so there is a Telegram link associated with my YouTube channel. You can just click on that link and directly you can ask me whatsoever things you have in your mind. You can ask me, and you can also give me some suggestions for my next video or something like that. Okay, and thank you very much. I think this session was designed only to give you, and I haven't missed a single thing from the basic maths chapter, right? I don't have missed a single thing. This was basically a one-shot series, but the thing is I haven't cut any portion of the syllabus to get it very quick finish, right? I have done that thing, so you can ask me anything. Okay, it was complete one, no? You can fully depend on it, and if you want a more practice problems like that thing, you can just also send me those things that sir, I want a more practice problems in it, right? So if you have practices more problems, that this will have stretched out to 3 hours 4 hour session. So I think students is now not having this much of time to get this thing clear. So let's hope for the best. Thank you very much, and bye.